Welcome back to college algebra. We are now going to be looking at solving radical equations. Again, we saw this in intermediate algebra. This is supposed to be a refresher. And actually, I think you guys all really liked solving radical equations. So we're just going to do a brief 4-question overview, and then I think you'll be totally fine. Let's take a look. Okay. As a reminder, to solve radical equations, you have to isolate the radical. Once the radical is isolated, then you actually raise both sides to the same power that matches the index. Okay, so let's take a look. And then, of course, we need to check our solutions. For number 1, the radical is isolated. It's a square root, so we have to square both sides. If I square both sides, that leaves me with x squared is equal to x plus 6 because the square root and the square cancel each other out. We have a quadratic equation, but it's not in standard form. So let's bring the x over and the 6 over. So now I have x squared minus x minus 6 is equal to 0. Can I factor? Do I have factors of negative 6 that combine to give me a negative 1? Yes, I do. So let's go ahead and rewrite this over here. So we know that the factors of negative 6 that give me a negative 1 are going to be negative 3 times 2, right? And then negative 3 plus 2 is a negative 1. So that becomes x minus 3 and x plus 2 is equal to 0. Awesome. Let's go ahead and solve. Each factor containing a variable gets set equal to 0. So x minus 3 equals 0, add the 3. So x is equal to 3. X plus 2 equals 0, subtract the 2, x equals a negative 2. We still need to check. So checking, let's take a look at the first one. We're going to check x is equal to 3. That means we have 3 is equal to the square root of 3 plus 6. Well, the square root of 3 plus 6 is square root of 9, and square root of 9 is 3. That checks. Now let's check x equals negative 2. I didn't mean to write that little line there. Oop, there it is. So replace x with negative 2. So we have negative 2 is equal to the square root of negative 2 plus 6. Negative 2 is equal to the square root of 4. Hold up. The square root of 4 is 2, not negative 2. So this is an extraneous solution. So we throw it away, and we find that our answer is simply 3. Cool. Take a look at number 2. Isolating the radical means that we are going to add 2 to both sides. That leaves me with the square root of 5p plus 6 is equal to p plus 2. I have the square root on the left-hand side that's isolated, so the opposite of square root is square, right? The index is 2. You don't need to see it to know that. So we square both sides. Be very careful. When you square a binomial, you write it out twice and you distribute. So on the left-hand side, we have 5p plus 6, right? We no longer need the square root because the square root and the square canceled. Now, I'm not going to take up space and write this out, but this is p plus 2 times p plus 2. When you do that math, you will have p squared plus 4p plus 4. Verify that. Expand p plus 2 squared, expand it, distribute to see that you get exactly this. We have a quadratic equation, so let's set it equal to 0 by bringing these two terms towards the largest term. P squared is the highest degree. So let's subtract 5p, subtract 6, subtract 5p, subtract 6, and that's going to leave me with 0 is equal to p squared minus p minus 2. Do I have factors of negative 2 that combine to give me a negative 1? Absolutely. So this leaves me with p minus 2 times p plus 1 is equal to 0. Double check that. P squared plus p minus 2p is a negative 1p minus 2. It checks. Set each factor containing a variable equal to 0 and solve. So we find that p is equal to a positive 2 and p is equal to a negative 1. We have to check each of these. I'm going to start with p equals 2. So we're going to plug that 2 in wherever we had a p. So we have square root of 5 times 2 plus 6 minus 2 is equal to 2. Let's check it out. 10 plus 6 is 16. 4 take away 2 equals 2. Yep, that's cool. Now let's check out the negative 1. Square root of 5 times negative 1 plus 6 minus 2 is equal to negative 1. Negative 5 plus 6 is a positive 1. Square root of 1 is 1. 1 take away 2 is negative 1, so it checks. And those are our two solutions. Very nice. I'm glad they both worked. That's very cool. Number 3, our radical is in fact isolated, but we have a cube root this time. So now we raise both sides to the same power that matches the index, which in this case is 3. So the cube root and the cube cancel each other out. We're left with 9x plus 3 is equal to 4 cubed. 4 to the third power is 64. Let's go ahead and solve. Subtract 3. 9x is equal to 61. Divide by 9. And let's see if 61 ninths can be reduced. It cannot. So our solution here is x is equal to 61 ninths. Now, because of the fact that when you actually take the cube root of a number, that number can be both positive or negative, that essentially means that we do not need to check that answer. I mean, you can. Go ahead and plug it in. It will always work out. For odd roots, it will always work out. You need to check those even, when you're solving for a square root or an other even root, you need to check that because you cannot take the square root of a negative number, right? That becomes imaginary. So because of that potential pitfall, we need to make sure that we check our solutions very carefully. Just like when we looked at problem number 1, when we plugged in that x equals negative 2, we saw that the square root of 4 is not going to equal negative 2, no matter what we do. So we have to verify that when we're dealing with even roots. But with odd roots, we actually have the luxury of not needing to worry, okay? Unless you do the math wrong, which I don't think you will. I think you're going to be fine. Last problem. Let's go ahead and isolate the radical. We're going to add 1 to both sides. So we have 2 cubed root of 2x minus 3 is equal to 1. Now, technically, if I wanted to divide by 2, that's fine. And then I cube both sides, and then I'll just have a fraction on this side, which we will anyways. So it's really up to you. But you know what? For the sake of consistency, I'm going to go ahead and divide both sides by 2. I will. Why not? Who cares? It's not like we can't deal with fractions. So we have the cube root of 2x minus 3 is equal to 1/2. By the way, you could have left the 2 and then cubed both sides, and you'd still have to cube the 2, which becomes 8. But we're going to prove that anyways. So let's cube both sides. That's what matches the index. That leaves us with 2x minus 3 is equal to, and then 1 over 2 times 1 over 2 times 1 over 2 is 1 over 8. Let's go ahead and add 3 to both sides and bring this up here. So we have 2x is equal to, and then we've got 1/8 plus 3. Remember, you need the same denominator in order to add fractions. So this is what I was referring to earlier, where you have to make them match. So you build them to be the same. And that becomes 25/8. Perfect. And now I have to get x alone. So we could divide by 2, which looks a little crazy, right? If I divided by 2 and divided by 2, I don't want anyone to panic. That's the same as multiplying by 1 over 2, right? But I'm going to prove that. So divide by 2, divide by 2. When you divide fractions, you have to keep the first fraction, switch from division to multiplication, and take the reciprocal of the second fraction. This is a 2. The reciprocal of 2 is 1 over 2. Finish this off, and you get 25 over 16. Notice I couldn't divide. There were no common factors, so I just multiply left to right. Because this is a cube root, I do not need to worry about checking my solution, and 25/16 is my final answer. Cool. I told you it would be pretty quick. Go ahead and try these problems in your practice block, and I think you're going to be just fine. All right, see you in class.